Okay, so let's look at 7.3b vectors, addition and scalar multiplication. So we have learned about vectors and what they are, and we have them usually in the component form. So we would have P and Q, or U and V. In this case, on these notes it says U and V. So the scalar is just a number. So we're going to refer to it as K. So the product of vector v and scalar k is the vector that is the absolute value of k times as long as v. To add two vectors geometrically, first position them without changing their lengths or directions so that the initial point of the second vector coincides with the terminal point of the first vector. So let's go ahead and show what this looks like. Okay, so I'm going to have vector v be 1, 3. So 1, 3. So I know this is vector v. And I'm going to use my scalar k as 2. So to do v times k, or k times v, then I just multiply. So it's going to be 2 times as long. So it's going to go up another, or over 1, up another 3. So this is at 1, 3. The other one's going to be at 2, 6 after you multiply. So it's twice as long. Okay. So it's kind of like whenever you think back to geometry, whenever we did dilations, we multiplied by a value and it made it so much bigger or smaller. Okay, so let's do our addition. So we're going to call U 2, 1 and V negative 2, 2. So 2, 1 is going to be right here. And then negative 2, 2. It's going to be right here. So this is U, this is V. So what we want to do is we want to go back. Let's go in between these. So it's going to go to here, back to here. Okay, so what we did was we went back to where we were. So it's kind of like I'm adding the V vector to the U, or the U vector to the V. But it got us to the same point, which was 0, 3. Okay, so we see how it is in the coordinate plane. So let's see how we can do it algebraically. So definition of vector, whenever we are adding them, we add the x values and then the y values. So let's do our last one that we just did. And v was negative 2, 2. So u plus v is going to be 2 plus a negative 2 and 1 plus 2. And so we ended up with 0, 3, which is the same thing we did right above. Okay, scalar multiplication, you're just going to multiply the whole thing by 2. So let's say we have, just like the one above, u is 1, 3. And we want k to be 2. So 2u is going to be 2 times our vector, which is 2, 6. Okay, a negative vector is where you are changing the signs of both x and y. So let's say that v is for negative 5. So negative v is going to be negative 4, positive 5. So 1, 2, 3, 4, negative 1, 2, 3, 4, 5. Okay, and then negative v would be 1, 2, 3, 4, up 1, 2, 3, 4, 5. So this is negative v, and this is v. Okay, the difference, what you will do is you will do u plus a negative v. So let's say u is 3, 4. V is negative 2, 5. So we want to do u minus v, which I'd rather write it as u plus a negative v. So that would be 3, 4 plus